morning. I am Viswanath, Assistant Professor, Institute of Aeronautical Engineering College. In this session, I am going to give a brief introduction to electrical circuits. Here, we are going to cover some basic definitions which are related to our subject, electrical circuits. So, here is the overview of my presentation today. That is basic definitions and then classification of elements. So according to modern electron theory of matter, structure of any matter is consisting of atom and then molecules, matter, solid, liquid and gas. So number of atoms constitute molecules, number of molecules constitute matter, and matter is further divided as solid, liquid and then gas. So atom is consisting of three particles. One is electron, proton and then neutron. Electron is represented with the letter E, and since it is having a negative charge, is represented with a negative symbol E minus, and then proton is represented with the letter P and it is having a positive charge, so it is represented with P plus. And the last one is a neutron. Neutron is having no charge, or it is said to be a neutral one. So these are the pictorial representation of electron, protons and then neutrons. Nucleus is consisting of protons and then neutrons. Nucleus is consisting of protons and neutrons, and electrons revolve around the nucleus, which are represented with the minus sign. So it is consisting of electron and then proton and then neutron. Neutrons are the stable ones which are having a zero charge. So coming to the definitions of these electrical circuits. First one is what is meant by electric circuit. Electric circuit is an interconnection of electrical elements, maybe series parallel connection, or the elements may be RLC elements or LC elements, or voltage and then current sources. Any number of elements connected either in series or parallel or in combination of series parallel. And next one is charge. Charge is an electrical property of atomic particles of which matter consists, and the units are coulombs for charge. Next one is according to law of conservation of charge. Charge can neither be created nor destroyed. It just transfers from one circuit to another circuit, and always the net charge in any circuit is zero, and the charge is either positive or negative, and like charges repel and unlike charges attract. Here it is represented with two positive charges, and when we brought two positive charges near, they repel each other, and when two unlike charges are brought together, they attract each other. So next one is what is electric current. Electric current is the time rate of change of charge and is measured in amperes, and it is mathematically represented as I is equal to dq by dt, and 1 ampere is said to be 1 coulomb of charge transferred in 1 second. So here it is represented the direction of current. Q is the charge which is transferred from one point to another point, is known as current, that is flow of charge. So here upper portion represents a less number of electrons, which is represented as low current, and lower portion represents a higher number of electrons, which is represented as a high current. So here a source is represented here, and the charge of electrons is transferred from one point to another point, and conventional current flow is from positive terminal to the negative terminal, and actual direction of current flow is from negative terminal to positive terminal. So we are following the conventional direction of flow of current. Here are some simple problems regarding electron and then charge. First one is, how much charge is represented by 4600 number of electrons. Each electron is having a minus 1.602 into 10 power minus 19 coulombs. So 4600 number of electrons will have a charge of minus 7.369 into 10 power 16 coulombs. Second problem, the total charge entering a terminal is given by Q is equal to 5t sine of 4 pi t millicoulombs. Calculate the current at time t is equal to 0.5 seconds. So current as per definition is I is equal to dq by dt, and Q is given as 5t sine of 4 pi t millicoulombs according to UV rule of differentiation. When we are differentiating UV terms, it is U dash, and then that is differentiation of U multiplied by V plus U multiplied by differentiation of V. So it is 5 sine of 4 pi t plus 20 t cos of 4 pi t milliamperes, and we need to calculate a current at time t is equal to 0.5 seconds. So substituting t is equal to 0.5 seconds, we can get here current as 31.42 milliamperes. Next one is voltage, or sometimes also known as a potential difference. It is the energy required to move a unit charge through an element. It is energy required to move a unit charge through an element, and the units are in terms of volts. Here two figures are represented, A and then B. Figure A represents 2 points A and then B with the polarities positive and then negative. So here we can write VAB as plus 9 volts, and in second figure polarities of A and B are marked as a negative and then positive, which is opposite to the figure in A. That is VAB, here we can write it as minus 9 volts. So we can say that VAB is equal to minus VAB in the second case. So based on the representation of polarities, the positive and then negative values are going to be varied. This potential difference, when compared to the normal practical life applications, we can compare the potential difference here in this case, that is tank A and then tank B are shown here, which are having the water levels at equal levels. Now there is no flow of current from one tank to another tank. Since two are at the same levels, no water is flowing from tank A to tank B, or in reverse case, tank B to tank A. And in the second case, tank A, water level is higher as compared to water level in tank B. So it is clearly represented as water is flowing from tank A to B. Since water level in tank A is higher as compared to tank B, here we can call it in terms of electrical terminology as potential difference. That is, potential of A is greater than potential of B, so that some electric charge or electric current is flowing from A to B in this case. This is the normal representation of potential or voltage as compared to electrical and normal terminology. Next one is power. Power is the time rate of expanding or absorbing energy, and it is represented in units as watts. So power mathematical representation is power is equal to dW by dt, and here P is power in watts and W is energy in joules and time T in seconds. Power can be written as dW by dt, and this can be further expanded as dW by dq and then dq by dt. So it is dW by dq is work done in moving a charge from one point to another point is represented as voltage, that is a potential difference, and I is rate of change of charge, that is dq by dt. So it is I. So power can be written as the multiplication of voltage and then current, and the law of conservation of energy to be obeyed in almost all the electrical circuits, that is sigma P is equal to 0, means here power delivered by the sources is equal to power absorbed by the elements. Power absorbed by the elements. So next one is energy. Energy is the capacity to do work measured in joules. The energy absorbed or supplied. Here we are representing as two terminologies. One is absorbed and then supplied. Energy can be supplied by sources and absorbed by the elements. So W is equal to integral T0 to T when time interval is considered, T0 to T, P times dt. So it can be represented as integral T0 to T, Vi, P power can be represented as multiplication of voltage and then current into dt. And most of the times power is measured in watts. So 1 watt hour is equal to 3600 joules. So coming to a simple problem, an energy source forces a current of 2 amps for 10 seconds to flow through a light bulb. If 2.3 kilojoules is given off in the form of light and heat energy, calculate the voltage drop across the bulb. So we need to calculate voltage drop across the bulb, and since it is given as 2 amps of current is flowing for 10 seconds, total charge delta Q is equal to I into delta T, that is 2 into 10, 20 coulombs of charge is moved. Next, voltage drop is written as delta W by delta Q, that is 2.3 into 10 power 3 divided by 20, that is 115 volts is the voltage drop across the bulb. Next one is find the power delivered to an element at a time t is equal to 3 milliseconds if the current entering at its positive terminal is I is equal to 5 cos of 60 pi t amperes, and the voltage is given as two problems. One is V is equal to 3I, and second one is V is equal to 3 multiplied by di by dt, and voltage is given as first one 3I, substituting the value of I, that is 5 times cos of 60 pi t. So the power here is power is equal to V into I, that is 75 cos square of 60 pi t watts. And since we need to calculate power delivered to an element at time t is equal to 3 milliseconds, it is power is equal to 75 cos square of 60 pi into 3 milliseconds. So it is given as 53.48 watts. And in the second case, V is given as 3 times di by dt. So it is 3 multiplied by di by dt. I is again 5 cos of 60 pi t. Differentiation of that one gives minus 60 pi multiplied by 5 sine of 60 pi t. That is minus 900 pi sine of 60 pi t volts. And power can be calculated as Vi. So it gives a value of minus 4500 pi sine of 60 pi t cos of 60 pi t watts. And again, by substituting time t is equal to 3 milliseconds, you can get the power as minus 6.396 kilowatts. So these are the basic definitions. Now coming to the classification of circuits, we have electrical circuit definition as interconnection of electrical elements is known as electrical circuit. And now the classification of circuits. First one is active circuit. A circuit which contains a source of energy generating element is known as active circuit. Source of energy generating element. The examples of this source of energy generating element is voltage source and then current source. Voltage source maintains constant voltage at its terminals irrespective of the load. Voltage source maintains constant voltage at its terminals irrespective of the load, a constant voltage. Next one is a current source delivers a current with respect to load. That is, as per the load requirement, the current may be either minimum to maximum value. Let us say we need a variation of load current some 2 to 5 amperes. So sometimes we need 2 amperes, or sometimes we need 4 amperes, and sometimes 5 amperes. So the value of current is varying with respect to load requirement. That is, current source delivers a current with respect to load. And next one is a passive circuit. Circuit consisting only passive elements. Only passive elements like resistor, inductor, and then capacitor is known as passive circuit. Resistor converts electrical energy into heat energy. That is, resistor consumes electrical energy and dissipates in the form of heat energy. And inductor stores energy in the form of a magnetic field. And capacitor stores energy in the form of electrical field. So these are the three differences of R, L, and then C. Resistor converts electrical energy into heat energy. Inductor stores energy in the form of magnetic field, and capacitor stores energy in the form of electrical field. And next one is linear circuit. Circuit following the principle of superposition and homogeneity is called linear circuit. Circuit following the principle of superposition and homogeneity. According to mathematical formulation, let y1 of t and y2 of t be the output of the circuit for x1 of t and x2 of t respectively. That is, if we select a circuit, we are giving inputs as x1 of t and x2 of t. Outputs are correspondingly y1 of t and then y2 of t. y2 of t. If the input of x1 is changed as a times, that is a1 times x1 of t and a2 times x2 of t, then the output is also changed accordingly, that is a1 into y1 of t and a2 into y2 of t. That is the principle of superposition and homogeneity. The circuit which obeys the principles of superposition and principle homogeneity is known as linear circuit. And vice versa. Next one is a non-linear circuit which does not follow the principle of either superposition or homogeneity or both is called a non-linear circuit. See the difference between the two. One is linear circuit and second one is non-linear circuit. Linear circuit follows the principles of superposition and homogeneity, and non-linear circuit does not follow the principle of either superposition or homogeneity or both. Next one is time invariant and time variant circuits. If the coefficients of a differential equation describing the circuit are constant, if the coefficients of differential equations are constants, then the circuit is said to be time invariant circuit. And time variant circuit is coefficients of the differential equation describing the circuit are functions of time then it is said to be time variant circuit. Next one is reciprocal and non-reciprocal circuit. Ratio of output in any element to input is constant even when the position of input and output are interchanged. Then the circuit is said to be reciprocal circuit. If the ratio of output in any element to input is constant, ratio of output to input in any element is constant even when the positions of input and output are changed, the circuit is said to be reciprocal. That in terms of two-port network parameters, if it is represented, it is following or obeying these conditions, that is Z12 is equal to Z21. In terms of admittance parameters, Y12 is equal to Y21, and hybrid parameters H12 is equal to H21, and in transmission line parameters, it is AD minus BC is equal to 1. Next one is a non-reciprocal circuit. If the ratio of output in any element to input is not constant when the positions of input and output are interchanged, then the circuit is said to be non-reciprocal circuit. Next one is a symmetrical circuit. Circuit is said to be symmetrical if the electrical properties are not changed or not affected when the input and output terminals are interchanged. That is, we consider a circuit, these are the input terminals and these are the output terminals. If these two are interchanged, then the electrical properties like current and then voltage, current flowing in any one element or voltage across a given two terminals is not changed, then the circuit is said to be symmetrical circuit. So this also obeys the principles like Z11 is equal to Z22, Y11 is equal to Y22, and then A is equal to D, and delta H, that is H12 and H21. Determinant of hybrid parameters matrix is equal to 1, that is H11, H12, and then H21, and then H22. So determinant of this matrix is equal to 1. Next one is asymmetrical circuit. The circuit is said to be asymmetrical if the electrical properties changes when the input and output terminals are interchanged. Only the difference is when the properties are changed, it is known as asymmetrical circuit. When the properties are not changing or not affected, it is known as symmetrical circuit. Next one is a classification of elements, active elements and then passive elements. Next one is linear and non-linear elements. And third one, unilateral and bilateral elements. And the last one, lumped and distributed elements. First one is active elements. The types of circuit elements that deliver power to a circuit or provide power gain. One is deliver power to a circuit or provide a power gain is known as active elements. First one is which deliver power, and second one is providing power gain. Either one of these two conditions are met when it is applied in a circuit, then it is known as active elements. So examples are energy sources like voltage sources and then current sources are said to be active elements, and semiconductor devices like transistors, operational amplifiers are said to be active elements since they are providing a power gain in the given circuit. Next one is passive elements. Electric circuit circuit elements that absorbs electrical energy and cannot supply energy to the circuit is called passive element. That is, they only absorbs electrical energy. So a passive circuit can either transform or store, but not deliver. It can transform or store the electrical energy supplied to it is known as passive elements. And examples for these passive elements are resistor, inductor, capacitor, and then transformer, likewise elements. Next one is linear elements. Linear mathematically represented as linear relationship. If x-axis parameter is changed, y-axis parameter is also similarly changed, the relation is said to be linear. If x-axis parameter is changed, accordingly y parameter is also going to be changed, then it is said to be linear. The same principle is applied here, that is which satisfies linear voltage current relationship. Linear voltage and then current relationship is known as linear elements, and linear relationship obeying elements are satisfying Ohm's law. By definition, Ohm's law is in a given circuit at constant temperature, current flowing through an element is directly proportional to voltage applied across it. That is, it is giving a linear relation. So it is also following Ohm's law. And next one is linear elements obey the law of superposition and then homogeneity. And examples are resistor, inductor, and then capacitor are said to be the linear elements. Next one is non-linear elements. As compared to the previous one, that is linear elements follow the principle of superposition and homogeneity, and it is following a linear relationship between voltage and then current. Non-linear elements are not following the principle of superposition and homogeneity, and the relation between voltage and current is said to be non-linear, whose values with respect to current and voltage is called non-linear element, that is, does not remain constant. Circuit parameters, either voltage or current or any other parameter, does not remain constant. And next one is current flowing and voltage across these elements have a non-linear relationship, and it does not satisfy the principle of homogeneity and then superposition laws. And examples are diodes, transistors, and then saturated iron core inductors are said to be non-linear elements. Next one is unilateral elements. Circuit elements whose characteristics change with the direction of current. That is, the characteristics either current or voltage is said to be changing when the direction of current changes from one direction to opposite direction. They are said to be unilateral elements. That is, it allows current only in only one direction, and if the direction of current changes, either it opposes the current flow or there will be a change in its some other behavior. And next one is impedance of unilateral elements varies with variations in the flow of current. That is, the direction of flow of current is changed. The impedance may be varying from minimum to maximum value. And examples are diode. Diode in forward biased condition, it allows current to flow, and during the reverse bias condition, it acts like open circuit. That is, in forward bias condition, it allowing current means it is resistance offered by the diode during the forward bias condition approaches zero, and during reverse bias condition, resistance offered by the diode approaches infinite. Next one is bilateral elements. Bilateral elements as opposite to unilateral elements, even the direction of current flow is changed, then the characteristics of V and I is not going to be changed. That is, it allows current to flow in both directions, and the characteristics V and I are going to be remains the same. Next one is bilateral element allows current in both directions, and resistance or impedance of the bilateral elements remains the same. That is, if we consider an element like a resistor, it is represented as some 5 ohms. Even the current is flowing from, let us say this point is marked as A and point B. Current flowing from A to B, or even current flowing from B to A. Resistance offered by the element resistor is 5 ohms. So next one is examples of bilateral elements are resistors, inductor, and then capacitor, some other power electronic devices, that is triac. Next one is lumped and distributed elements. Physically separable elements such as resistor, capacitor, and then inductor are called lumped elements. And distributed elements are one which cannot be separated for the purpose of analysis. Analysis here means mathematical analysis. When we are doing mathematical modeling or mathematical analysis, we cannot separate this one. Those are transmission lines are having a distributed resistance and distributed capacitance as well as distributed inductance throughout its length. So these are the differences of lumped and then distributed. And these are some of the basic definitions needed while drawing a circuit or analyzing a given electrical circuit. First one is a branch, which represents a single element such as a voltage source or a resistor. Here branch is this one, A and B. One element is connected 5 ohms. This is said to be one branch, and this is another branch, that is B and then C. Between B and then C, one another element is connected, that is 2 amps current source and 10 volts, which is connected between A and B. These are said to be branch. Next one is a node. Node is the point of connection between two or more branches. That is, here at this point B, we are having 1, 2, 3, and then 4 elements. So it is the interconnection or connection point of two or more branches is represented as node, and loop is a closed path. If we consider this one, A, B, C, and then A, this is said to be one closed path. As we are starting from 10 volt source, the next one element is 5 ohms and then 2 ohms, and return back to again 10 volts with a negative polarity. So it is loop. So B is a branch and node is N and L is the loop, and there is a relation between these three, that is B is equal to L plus N minus 1, and the next one is a series and then parallel. If the current flowing through all the elements connected in one way is same, then they are said to be connected in series. And if the elements, that is, if the elements connected between the 2 points are having the same voltage, then they are said to be in parallel. Here, between B and C, the elements connected are 3 ohms and then 2 ohms. These two are said to be connected in parallel. And the series connection here is, let us say, one resistive element and then one inductor element is connected by a source. Then the current carried by these two elements, current carried by the two elements R and L is same. So they are said to be connected in series. And parallel connection here means if we are having one voltage source and some number of elements, maybe R, L, and then C. So these R, L, and then C are having the same voltage applied across these 2 points. Let us say this is point A and then this is point B. So R voltage across resistive element and then voltage across inductive element and voltage across capacitive element, all are same. So they are said to be connected in parallel. So these are the electric circuit symbols generally followed while representing elements in circuits. So open switch is represented with 2 lines in which 2 are not connected, and closed switch is represented with 2 circles joined with 1 line, and lamp is with this symbol. Voltmeter and ammeter. A circle with indication of V indicates voltmeter and ammeter with this symbol, and battery, 1 small line and 1 big line, and fuse with this symbol, and resistor, and then buzzer. With this we conclude this session, which is covering the basic things, that is basic definitions and classification of circuits and then classification of circuit elements. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.